In this video, we'll be doing an example of net present value, which is just the sum of multiple different present values. So in the example that we discussed last week, we wanted to look at, say, Mr. Hong had a various different debts to Mrs. Nakamura, $200 due in 1 year, $500 due in 2, and 2,000 due in 4. But Mr. Hong wanted to know how much does he need presently, like right now, in order to pay that off. And again, the answer is not just a sum of the three because we're going to assume that the amount that he has right now will grow based on interest. So if properly invested or whatever, that our assumption is that it's growing. His money is growing at 6% compounded monthly, or her money, whoever has the money, will be undergoing compound interest, which means that we don't actually need to have as much presently to pay off all those debts, given that our money should be growing. So basically, we want to know what's the present value of each account. Basically, well, how much is this worth going back in time, or again, using the present value formula to do that, which is again the future value multiplied by 1 plus the periodic interest rate to the capital N power. And then we calculate the present value of the second and the present value of the third, which leads us to the net present value of all three of those. So this statement would tell us exactly how much is needed to pay off all those debts at once. So net present value is usually very similar. Let's go ahead and read this. Suppose that you could invest $18,000 in a business which guarantees cash flows at the end of years 2, 3, and 5. Assuming 7% compounded annually, find the net present value while taking into account how much was invested. So in this case, this is very similar, but we're also adding an additional investment cost into the mix. So it's kind of like, let's say I have $18,000 and I want to invest it. Let's say that a particular business could guarantee payouts, these particular payouts, $5,000 after 2 years, 12,000 after 3, 7,000 after 5, and we want to know, is this worth the investment? Basically, what's the net present value when taking into account the upfront cost or the investment cost? And a common mistake would be to just say, okay, this adds up to $24,000. Yes, that's a good investment because this is less. I'm gaining money. But since we're assuming that our current money is gaining interest at 7%, and if you're thinking to yourself, 7%, that's not very realistic, especially given that the market has been crashing. And everything's on fire, metaphorically speaking. Anyways, so basically we want to take interest into account. So this, and again, so the idea would be, well, this is growing over time, and it becomes a little bit confusing. Well, how do I know? It's growing into three different sums. Basically, it's helpful if we write it using an equation of value such as the previous. But basically, what we want to do is just find the net present value of all these. So let me move to my whiteboard and let's get started. So the first cash flow was $5,000 after 2 years. So let's go ahead and write out the present value of that one specifically. So our goal was to have $5,000 paid off in a total of 2 years. So also, I don't want to forget the fact that the periodic interest rate is R over N, and the number of periods is going to be the number of times compounded times the time frame. Each one of those cash flows has a different time frame, so it's important to keep each of those in mind. But in all of these, the periodic interest rate, since our annual percentage rate was assumed to be 7%, the periodic would be 7%. And our assumption was that it was compounded annually. That's going to make our life a little bit easier, meaning that little n is equal to 1, because it's only being compounded once per year, which is greatly going to simplify the math. So anyways, going back to the whiteboard, little n is going to be 1. So our periodic interest rate is just also equal to the APR, which is always the case when it's compounded annually. But it's more typically going to be compounded monthly, so you'll be putting a 12 there. And then the number of times compounded. Now this is going to be dependent on each cash flow because each one has a different time frame. But the first one was after 2 years. So it's going to be, again, n is 1, the number of little n, the number of times compounded, and the time frame is 2. So capital N should be just 2 for the first one. So when I'm plugging it all in to find the present value of that first cash flow, the goal was to have $5,000, or in that case, we were wondering if our investment is worth it. So one of our investment would pay off $5,000, and we want to know how much is that investment currently worth today. What's the present value of that $5,000? So we need to take into account the interest rate, which is 7%. So it's going to be 1 plus 0.07, and it's going to be to the negative n power, which was negative 2 for all those particular parameters. And, or, 1 plus 0.07 is, of course, 1.07, so it will make more sense if I just write that all together. And then I could do that individually. Let's just look at what that amounts to just to check the sense of this before we move on. So if I do 5,000 times 1.07 to the minus 2, present value should always be less because money always grows over time, assuming it's compounded interest. And the present value of that $5,000 cash flow will be 4,367 and some change. Also, I wanted to mention that the term cash flow often could mean that it's a payout happening incrementally, like say for example every month. Some cash flows are done on a month-by-month basis, but this example did not indicate that it was being paid out every 2 years. It's not exactly clear, but the book won't necessarily specify. But usually it should be made clear if it's 5,000 being paid out every 2 years. That's actually what we're going to get into, is how does that work if it's going to be continually paid out. Anyways, but we were just assuming a singular payout of $5,000 after 2 years. And so presently that cash flow is worth 4,300. And we want to know, well, what's the sum of all the cash flows? So we also had a $12,000 payout after 3 years and a $7,000 after 5. So 12,000 is going to be the future value of the second cash flow. And again, it's the same interest rate assumed for everything. So 1 plus the periodic interest rate. And this one will be to the minus 3 power, because this one is undergoing 3 years of growth instead of 2. And again, compounded annually once. So it's just 3 times 1. And for the last cash flow, that will be plus 7,000 times 1.07 to the minus 5 power for the 5 years it will take to grow. And that's going to be the sum of all 3 present values of each of those. So putting the rest of that into my calculator, I can then add that together. So that would add the present value of the second, and then adding the present value of the third. I could do those all in one step. But I could just do that all together. And that would give me a sum of, let's see, what was it? It was 19,167 cents. Typically, we're just going to round our financial numbers to the nearest cent. And that's generally what you can assume for writing your answers. But also in that example, our initial investment was $18,000. So if we're basically, if we then subtract, excuse me, if we subtract off the initial investment, we could get the net present value, which is one of the ways. If you just Google net present value, you'll probably come up with a formula that looks something like this: the sum of all the present values minus investment, something like this. Oops, investment. Oops. So you can't see what I'm doing. Let me fix that. So this is typically how a formula would look online, but that's just a way of saying that we're going to add up all of the present values. That's exactly what I did right there, right? I added up the present value of the first cash flow, second, and third. Cool. And then I'm going to take away, well, how much would it cost to purchase those cash flows? And that's exactly what I'm doing here. The sum of all three minus the investment. And obviously we want to be making money, and in this case the net present value is positive, so that's good. $1,153.67 is the net present value. So that's an example of net present value. See you in the next video.